Okay, this is complex numbers, part 6. This is from section 6.6 in the textbook. In this video, we're going to start talking about how to find the roots of complex numbers. First of all, let's talk about how you'll know how many roots a number will have. If you're willing to use complex numbers, and not just the real numbers, it's actually going to be quite simple. But for a few examples, there are 2 square roots of the number 9. Now this is also a real number as well as being a complex number, but it has 2 square roots that you're very familiar with. Root 1 is the number 3, root 2 is the number -3. What it means for something to be a square root is that if you take the square root and you square it, that will give you the number. So 3 squared is 9, -3 squared is also 9. So that's why those are both square roots. Let's look at the the real number. Well, it is both a real number and a complex number. C equals -36. It also has 2 square roots if you're willing to work with complex numbers. If you're just doing real numbers, then you say it has no real square roots. The first root would be 6i, and the second root would be -6i. And again, these are square roots because if you were to square the root, either root squared, like -6i squared would be 36i squared, which would be 36 times -1, which would be -36. And if you take -6i and you square it, you get the same result. All right, another example would be, say, if you talked about 4th roots. All right, I'm trying to pick numbers where it's not too complicated. So the number z equals 16 actually has 4 4th roots. All right, one root is 2, another is 2i, -2, and -2i. So there's 4 distinct 4th roots. Any one of these raised to the 4th power, 2 to the 4th, 2i to the 4th, -2 to the 4th, or -2i to the 4th will lead you to the number 16. So that's why 16 has 4 4th roots. All right, now it does generalize to every non-zero complex number has nth roots. So if you were talking about cube roots, every non-zero complex number has 3 cube roots. Or if you're talking about 8th roots, every non-zero complex number has 8 8th roots. So it's fairly easy to remember. Now, there is a theorem that will help you find all the roots. And it's kind of complicated. It's a formula. So here it goes. For a positive integer n, the complex number has exactly n distinct nth roots, and it's given by, here we go, root k plus 1 is equal to the nth root of r times the cosine of theta plus 2 pi k all divided by n plus I sine of theta plus 2 pi k divided by n. And you can use k equals 1, 2, all the way up to n minus 1. So you keep changing out the k values to get the different roots. This is not exactly the same as what's in the textbook. I changed the labeling here just a little to make it clearer. Now, this is the version for radians, where you have 2 pi. It could be switched out, and you could put 360 degrees and have an equivalent formula. All right, let's look at one example. Find the square roots of z equals 20 times the cosine of 240 degrees plus I times the sine of 240 degrees. Okay, so this is already in the trig form, and that's what we'll kind of focus on first. If we have the trig form of a complex number, finding roots of it. Okay, so in this problem, the r value is 20 and the theta is 240. And since we're doing square roots, n will equal 2. If you're doing cube roots, n will be 3. If 4th roots, n will be 4. 5th roots, n will be 5. So for square roots, n will equal 2. So here's the version of that formula I was just showing you. but it's written in degrees. I've got 360 degrees there. Since the original problem was in degrees, we'll work this in degrees. Okay, so basically what we'll do is try the different values for k. K can be 0, 1, 2, all the way up to n minus 1. Since n is 2, 2 minus 1 is 1. So we're going to do k equals 0 and k equals 1. And that's going to give us 2 different roots. And since it's square roots, we know there'll be 2 of them. Okay, so first we're going to take k equals 0 and substitute it into this formula. All right. Also using the value that we have for r, we said that r would be 20 and theta would be 240. Okay, so if we put in 0 for k, it's kind of messy looking, but you'll have root 0 plus 1, so that's going to be really the first root. You're going to be taking the square root of 20, and then the cosine, the angle will be 240 plus 360 times 0 for k divided by 2 plus I sine. This will always be the exact same angle. And when you simplify it, this will tell you the first root is going to be the square root of 20 times the cosine of 120 degrees plus I times the sine of 120 degrees. Right. And then when you try k equals 1, you'll get a different square root. So here I put in 1 for k. R stays 20, theta stays 240, right? Because you have the same original number, you're just changing out which root. And this time when you use 1 for k, you'll get an angle that is 300 degrees. So the square root of 20 times the cosine of 300 plus I times the sine of 300. Okay, so this is one square root, this is the other, and those are in trig form, and there are 2 of them.